Okay, so in this lecture, we'll look at how to, still looking at how to name organic molecules. And in this case, looking at a feature what is known as kind of common way to name things or a trivial way to name things. So if we took this, so what I have in green, let's assume that's the parent. So just a really long hydrocarbon chain. And then everything in black is a substituent on the parent. So we're going to call the green the parent, and then everything else is a substituent on that parent. Okay, so if you had a 3-carbon chain on the parent, then that would simply be propyl. Or sometimes you see it called N-propyl, right? N-propyl, where the N stands for normal. So if you had a 3-carbon chain, there's another way that you could attach 3 carbons to the parent, and that would be like this, where off of the parent you have a 1,2 carbon sequence, and then on carbon 1 of the substituent you have, so we'll call that 1 prime, you have another carbon. So that's 3 carbons, but they're not linear off of the parent, they're branched off of the parent. And this is what's called isopropyl. Okay, if you have 4 carbons, and so you could have 4 carbons in a straight chain off of the parent, so 1, 2, 3, 4, and then that would be butyl, or maybe you see it called N-butyl sometimes. So if you had 4 carbons, there's 3 other ways that you could arrange those 4 carbons. You could have a 1, 2, 3 carbon sequence off the parent, and then on the first carbon you have another carbon, so a methyl group there. So we'll call that 1 prime, for example. So this is what's called a sec-butyl, or sometimes just called S-butyl. Okay, so or you can have 1, 2, 3 carbons off of the parent, and then the methyl group could be attached to the second carbon of the 3-carbon chain. So again, that's still 4 carbons, they're just branched differently. And so if it looks like this, it's what's called isobutyl. So if you notice, iso is not hyphenated, but N is hyphenated and sec or S is hyphenated. And then the other alternative would be, that's 4 carbons again, but now you only have 2 carbons off of the parent, right? The green is the parent. And then on the first carbon, then you have 2 methyl groups on the first carbon. So now you just have, so this is what's called tert-butyl or T-butyl. So it kind of looks like chicken foot. So it's an ethane chain with 2 carbons on the first carbon. So that would be the common way to name these substituents, or the trivial way to name them. You could use a systematic way to name them. For example, isopropyl could also be called 1-methyl ethyl. Right? Notice they both end in YL because they're all substituents. So the ethyl would be coming from here, 2 carbons, so that's the ethyl, and on the first carbon of the ethyl there's a methyl, so 1-methyl ethyl. And if you wanted to do that for the sec-butyl, so that's a 3-carbon substituent off of the green parent, and on the first carbon there's a methyl, so a sec-butyl could also be called a 1-methyl propyl, right? Propyl because of the 3-carbon off of the parent, and 1-methyl because of the CH3 on the first carbon of the propyl. So then what would be the systematic way to name isobutyl? So again, you have a propyl off of the parent 3-carbon chain off of the green. So, and in this case, it's a 2-methyl propyl. So isobutyl is the same thing as 2-methyl propyl, or Sec-butyl is the same thing as 1-methylpropyl. Isopropyl is the same thing as 1-methylethyl. And then if we wanted to do the same thing for the tert-butyl, so now then it's kind of like the parent of the substituent is an ethyl, and there's 2 methyls on the first carbon. So the tert-butyl could also be called 1,1-dimethyl ethyl. So you see it both ways. Okay, so now let's take some molecules and name them. When you have these, so you could do the same thing with 5 carbon chains, and there's many different ways to branch 5 carbons, but you're only going to have to know the 3 carbon and 4 carbon ones that are branched. So propyl, isopropyl, butyl, sec-butyl, isobutyl, and tert-butyl. Okay, so if we take some molecules, oh, and let me make the point also. So when hyphenated, you alphabetize based on the first letter after the hyphen. So tert-butyl, so you ignore the tert and you alphabetize based on B. Sec-butyl, you ignore the S and you alphabetize based on the B. Since isobutyl is not alphabetized, you alphabetize based on I. So same thing with isopropyl, you alphabetize based on I. If N-propyl was used, you would alphabetize based on P, or of course if propyl was used, you alphabetize based on P. And same thing for butyl, alphabetize based on B or the B. So just remember, those that are hyphenated, you ignore the prefix and don't use that to alphabetize. Okay, so if we take a molecule like this and name that, and let's take some others. Okay, and let's take one more. Okay, let's name these 3 molecules. Okay, so for this first one, what's the parent? Well, you have a 6 carbon chain there in a ring, and then you have a 2 carbon chain here. Well, no, sorry, you have a 3 carbon, would be the longest. Right, that would be 3 carbons. Well, 6 carbon beats 3 carbons, so the cyclohexane is the parent. So we'll ignore that. So then what you would want to recognize next is that substituent is a tert-butyl, right? It's 4 carbons, 1, 2, and then 3, 4. And it's branched like the chicken foot, so that's the tert-butyl, right? And then this would be a bromo. So which one comes first in the alphabet? Well, you alphabetize based on B and B, so bromo beats butyl. So you're going to number 1, 2, 3, 4. So the bromo would be numbered at carbon number 1. And so again, when you have rings, you always start numbering at one of the substituents. So you either start numbering at the carbon with the bromo or the carbon with the tert-butyl. And since you would get 1, 4 either way, right? If you numbered here 1, 2, 3, 4, either way it's 1, 4. And so then you resort to the alphabet. So since bromo comes first in the alphabet, it gets number 1. So there would be 1 bromo, and then 4 tert-butyl, and cyclohexane. Okay, so for this one, the longest carbon chain is here. I mean, you should always check. I mean, maybe I'm trying to be tricky and maybe I made it here, or you'd always want to basically start at each methyl. Right, so those are all methyls, those are all ends of lines, so you should always start at each one and trace out the different carbon chains and see if you can find one that's longer. Hopefully the blue is what's longest. I think it's going to be 2, 3, 4, 1, 2, 3, 4, 5. Yeah, the blue is definitely the longest chain. Okay, so the blue is the parent, so let's get rid of that. And which end are we going to number from? So if we number from the left, the first substituent is the carbon number 3, and if we numbered from the right, the first substituent would be a carbon number 6. So we're going to go from the left because 3 beats 6. So we always number to keep the first substituent as low as possible. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oh no, 11. Let's get rid of 1 carbon because I can't remember what 11 is called. And I'm afraid if I erase that, it's going to erase the whole thing. Jeez. What's 11 carbon? Let's see what happens. Okay, that's not too bad. Since I can't remember what 11 carbons is called, we'll just shorten it by 1 carbon. So now it's a 10 carbon chain. But still numbering from the left would be the lowest as possible. Okay, so obviously this is a chloro. So we have a 3 chloro. And then what is this? That would be, so that's 3 carbons, and it's branched, so that's the isopropyl. So we have a 5 isopropyl. And then the other substituent would be that, so that's 4 carbons, and it's branched towards the parent, right? So if it's branched at the first carbon, that's sec-butyl. If it was branched at the second carbon, that would be isobutyl. So this is a sec-butyl. So it's a 6-sec-butyl. Okay, so which comes first in the name? So if you remember, we alphabetize sec-butyl based on the B, so it's going to come first. So 6-sec-butyl, and then chloro and isopropyl we alphabetize based on the I, and then 10 carbons would be decane. So 6-sec-butyl, 3 chloro, 5 isopropyl, decane would be that molecule. And this molecule, so we have a 5 carbon ring, and then we have a 3 carbon chain here and a 3 carbon chain here. So the 5 carbon ring is the longest, so that's going to be the parent. So the parent's going to be cyclopentane. And then for substituents, we have a bromo. And then this would be a butyl. No, that's not a butyl. That's 3 carbons, so that's propyl. And then this would be, so total of 4 carbons, so it's either butyl, sec-butyl, isobutyl, or tert-butyl. And this is the one that's got a 1, 2, 3 carbon chain with the carbon at number 2, so that's the isobutyl. So you would either number 1, 2, 3 or 1, 2, 3. And so the numbering scheme would be the same either way. So you're going to have to resort to the alphabet. So bromo's at 2 no matter what. So iso is going to come first in the name, or it's going to come before propyl. So we're going to name this, so we're going to number, isobutyl is going to be number 1, and the propyl is going to be number 3. So we would have 2 bromo, and then 1 isobutyl, and then 3 propyl. All right, so we don't order things in the name based on the number, we order things in the name based on the alphabet. But if the numbering scheme is the same, we can use the alphabet to decide where to start numbering it from. So 2 bromo, 1 isobutyl, 3 propyl. Cyclopentane would be the molecule. Okay, and then you should be able to go the opposite direction. So, for example, 3 fluoro, 4 isopropyl, 4-isobutyl nonane. So maybe I give you the name and ask you to draw the structure. Or let's see, 1,1-dichloro, 2-tert-butyl, cyclobutane. And I have a problem, right? Butane. So my name is wrong because this should become before the chloral in the alphabet. So we need to change some things here. So let's move this to the front. And then we'll move this there. Let's get rid of that hyphen and put a hyphen here. And then put this at the end of the name. Okay, so now that's a proper name because it's in alphabetical order. Okay, so let's draw these two molecules. So let's see. So nonane. So 1, when you put your pencil down, that's carbon 1. So 1, and then up to 2, 3, 4, 5, 6, 7, 8, 9. So go ahead and draw the parent first, and then number it. Doesn't matter which end you start numbering from. So let's just start numbering from the right. Why not? So now that you've defined what carbons you want to be each number, then that tells you where to put everything else. So carbon number 3's got to have a fluorine. So we'll put an F on that carbon. So draw a line and put a fluorine there. Let's see, 4-isopropyl. So carbon 4 needs to have that on it. And 4 needs to have an isobutyl as well. So isobutyl is 1, 2, 3 carbons with a branch at the second carbon off the parent. Okay, so that would be the molecule. So cyclobutane would be a 4-membered ring. Doesn't matter how you number it. You can make any carbon number 1. But now everything else has got to be in the right spot now. So on carbon number 1, right, you have 2 chlorines, and on carbon number 2, you have a tert-butyl. So that's a 2-carbon chain with 2 methyls on the first carbon. So that would be a tert-butyl. This name is still not right. No, this name is right. Because you would start numbering with the chlorine, right? Because then it's 1, 1, 1, 1, 2. Whereas if you started numbering with the tert-butyl, it would be 1, 2, 2, 1, 2, 2, and 1, 1, 2. Right, so those are the same, and then you go to the next spot, and then that's the point of difference. So 1, 1, 2 is better than 1, 2, 2. So that is the right name for the molecule. Okay, one more. Let's see. So let's say 1 bromo. Let's see, what have we not used yet? Isopropyl, isobutyl. We didn't use sec-butyl yet. So let's say 5 sec-butyl. 4, 5 diethyl decane. Okay, so start with the parent, decane, 10 carbons, 1, 2, shoot. I'll do that. Put your pencil down as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so a mistake that students make all the time is, okay, they know that bromine needs to be on carbon number 1, for example, so put the bromine there. And so what happens when you do that? You just lost a carbon, right? Because that carbon was supposed to be number 1, but now at the end of that line is a bromine, so that is no longer a carbon. That's the way you interpret the structure. So now this becomes carbon 1, and you have 2, 3, 4, 5, 6, 7, 8, 9. So now you only have a 9 carbon chain. So that's not what we want to do. Right, so that is carbon number 1. and bromine needs to be attached to carbon number 1, so you need a new line, and then attach the bromine, right? So now you still have that carbon as carbon number 1. And 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 5 has a sec-butyl. Get this 5 out of the way. So sec-butyl is 1, 2, 3 carbon chain with a methyl at the first carbon. And then 4 has an ethyl, so that's a 2 carbon chain. And then 5 also has an ethyl. So you could draw it like that, that's perfectly fine. You could have drawn it down here like this. Whoops. That's fine as 2, and that's probably how it will commonly be drawn. But it doesn't matter to me. As long as you have things attached to the right carbon, that is good enough. Okay, we'll stop there.